Rotary encoder. So I've got a rotary encoder here, and it's a Bourne's 5-volt DC rotary encoder. I can simply turn this. It looks like a potentiometer, but it's complete continuous rotation. And what it does is it needs 5 volts and ground, so I've got it connected here, and it's got a couple of channel outputs. I've only got one channel connected, the A channel, and that is simply pulsing on every time it does a fraction of a revolution. So it's a bit like having your magnet on a wheel, but really it's a disc with many holes in. So let's have a look at the data sheet of this. Okay, so it's a 5-volt DC, 128 pulse optical encoder. Okay, so what that tells me is it does 128 pulses for 1 revolution. So it's basically got a disc inside with 128 holes in it, and every small amount of revolution it will give you a pulse, every 1/28th of a revolution. Okay, so looking at the data sheet, how do we connect it? Going through the data sheet, I can just see there's a terminal diagram there. Ground, no connection, channel A. VCC is your 5 volts. Channel B, I'm not actually using channel B. How do we program it? Well, if you've watched the one with the Hall effect sensor, it's exactly the same program. So if you don't understand that, just go on to the Hall sensor one. Basically, I've connected it to pin 2 and I've put it onto a digital interrupt. And all that interrupt does is count every time it gets a pulse. So let me just upload that. Okay, so we should have some numbers streaming through. At the moment they're 0. What I'm going to do is rotate the encoder just a small amount, like that, and you can see that it's on 22 already. So I can just rotate the encoder a very small amount and it changes the values very quickly. So it's very sensitive for looking at rotation. Any small amount of rotation is picked up quite quickly, so it's very good for looking at shaft rotation or if high accuracy is needed. Notice that it still counts up whether I'm going left or right. You can actually do that with your code. You can actually change that. That's where you use channel B. Channel B is looking at the direction, but I'm not going to look at that in this instance. So we're just assuming that we want to measure a rotation, and you can see that it increases on every amount of rotation.